Hello friends. Hope you all are fine. In this video we learn about 7-segment display with a ladder diagram explain. Seven-segment displays are the output display device that provides a way to display information in t form of images or text or decimal numbers, which is an alternative to the more complex dot matrix displays. It is widely used in digital clocks, basic calculators, electronic meters, and other electronic devices that display numerical information. It consists of 7 segments of light-emitting diodes, LEDs, which are assembled like numerical 8. Working of 7-segment displays. The number 8 is displayed when the power is given to all the segments, and if you disconnect the power for G, then it displays the number 0. In a 7-segment display, power, or voltage, at different pins can be applied at the same time, so we can form combinations of display numerical from 0 to 9. Since 7-segment displays cannot form alphabets like X and Z, so it cannot be used for the alphabet and they can be used only for displaying decimal numerical magnitudes. However, 7-segment displays can form alphabets A, B, C, D, E, and F, so they can also be used for representing. Therefore, Boolean expressions for each decimal digit that requires respective light-emitting diodes, LEDs, are on or off. The number of segments used by digit 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are 6, 2, 5, 5, 4, 5, 6, 3, 7, and 6 respectively. 7-segment displays must be controlled by other external devices where different types of microcontrollers are useful to communicate with these external devices, like switches, keypads, and memory. Let's start how the ladder logic can implement 7 segments outputs. According to the type of application, there are 2 types of configurations of 7-segment displays: common anode display and common cathode display. In common cathode 7-segment displays, all the cathode connections of LED segments are connected together to logic 0 or ground. We use logic 1 through a current limiting resistor to forward bias the individual anode terminals A to G. Whereas all the anode connections of the LED segments are connected together to logic 1 in a common anode 7-segment display, we use logic 0 through a current limiting resistor to the cathode of a particular segment A to G. Common anode 7-segment displays are more popular than cathode 7-segment displays because logic circuits can sink more current than they can source, and it is the same as connecting LEDs in reverse. Applications of 7-segment displays. Common applications of 7-segment displays are digital clocks, clock radios, calculators, wristwatches, speedometers, motor vehicle odometers, radio frequency indicators. Network 1 is developed to obtain output Y1Q0.0, according to the condition that when majority of inputs are high, output Network 2 is developed to obtain output Y1, Q0.0, according to the condition that when A equals B equals C equals D equals 0, 1, output Y2 is high. as we can see in network 2, in order to get Y2. Output Y1 is high whenever any of the three inputs are high irrespective of the remaining 1 bit. Hence in total number of combination, only these 4 combinations ABC, ABD, BCD and ACD are there which have 3 or more than 3 inputs in high state. Hence this can be accomplished by connecting these combinations in series with parallel to each other as shown in ladder diagram above. Output Y2 is high in only 2 conditions, whenever all the inputs are set to 1 or are reset to 0.